Hello, welcome to the Henstitute, and we're going to talk about series circuits. So as you can see to the right, I have three resistors, R1, R2, and R3, that are connected up to some voltage source. So our battery over here is our voltage source. Let's say that this is a 9-volt battery connected across these resistors. And just to make it a little bit easier, let's say that this is a 3 ohm resistor, and this one is a 2 ohm resistor, and this one is a 4 ohm resistor down here. So whenever you have resistors in series, the total or equivalent resistance is merely the sum . So in this particular case, if I ask for the equivalent resistance or the total resistance, I would just take 3 plus 2 plus 4, and 3 plus 2 plus 4 is 9 ohms. So the equivalent resistance of this combo is 9 ohms. And when you use that, we can also figure out how much current is going to flow through this battery or flow from this battery, because we know that according to Ohm's law, that the current would equal the voltage divided by the resistance. So if I take the total voltage and the total resistance, I can find the total current. In this particular case, I have a 9-volt battery connected across 9 ohms of resistance. That's going to give me 1 amp of current. So you can actually do it either way. Conventional current is to go from positive to negative. So I'm going to do that. That means 1 amp of current is coming out of here as it flows here. Since there is only one path, 1 amp of current has to flow through this thing. And then it eventually comes down here, and 1 amp of current has to flow through this one. And eventually over here, 1 amp of current has to flow through that one, because 1 amp has to get back to the battery. Now my other idea is, you imagine this 1 amp is taking off with 9 volts of energy per coulomb, basically a joule per coulomb. So if it's 1 amp, that's 1 coulomb per second. So it's sending out 9 joules every second. It's not going to spend all that money on this first resistor here. However, we have what we call a voltage drop. And that voltage drop can also be found with Ohm's law. It would be the current times the resistance. So on this particular one, it would be the 1 amp times the 3 ohms. And therefore it is dropping 3 volts here. So this one is going to, sorry about that, this one is going to use 3 volts. This one would use 2 volts, and this one would use 4 volts. And sure enough, 3 plus 2 plus 4 is 9 volts. It uses up the total voltage. So one of the things that's kind of cool, in series, you have only one current, but each of the resistors is going to drop or use a different amount of voltage, but they add up to whatever the total voltage is. Because my example is they're using a little bit, so if they drop 3 volts here, you imagine this 1 amp now only has 6 volts left because it used up 3. It spins another 2, so when it comes here, it only has 4 volts left, and when it comes back to mom and dad battery, it's got 0, because it's going to get mom and dad battery to give them some more money. So that's all we have on series circuits. So just remember that with a series circuit, with our series circuit, we are going to have one path, so one current, but we'll have multiple voltage drops, but they add up to the total. That is all we have for the Henstitute on series circuits.